Morning, students. Today is going to be an asynchronous learning day. I have to pick my daughter, or I have to watch my daughter all day. Her daycare is closed for a while. Anyways, here's a warm-up. Couple questions. Try them. Hit pause on the video. I'm going to go over them shortly and explain the answers. Okay, so let's go over this. We know we have two parallelograms. They're similar, which means opposite sides are congruent. So this x is the same as this side length, so I'm going to call this x as well. And we have to use the information on the left to answer the questions. Find the ratio of the perimeters. Well, the ratio of the perimeters is the same as the ratio of the sides. So if I can find x, then I know the side lengths. And I already did that work down here. So here's what they do. They give us the ratio of areas. 150 over 24. That's equal to a squared over b squared. So I need to then give it so it's just a over b. But before I take the square roots of all sides, I'm going to reduce this down. 150 over 24 is the same as 25 over 4. And then that's what a squared over b squared is equal to. So then I'll take the square root to get the ratio of sides. So that's what we get here. 5 over 2 is the ratio from shaded to unshaded. So then number 2 says solve for x. Well, if 13 over x is equal to the ratio of sides, 5 over 2, we cross multiply, and I end up with x equaling 26 over 5 centimeters. Okay, quote for today. And just, that is the wrong page. All right, so what we're going to do is we're going to look at circumference and arc length. We'll watch that video when I see you guys again. Today is 11.4. It's circumference and arc length. First, we're going to talk about what is circumference. Well, circumference is the distance around a circle, right? So, oh, I thought that was in here. This circumference is the distance around the circle. Now, when we say distance, some people like to also think of that as perimeter, right? That's the distance all the way around. That's perimeter. There's two different formulas you could use. You don't have to write all of this, but the circumference of a circle is the product of pi and its diameter, but the diameter is the same as 2 times the radius. So pi d is one of the formulas for circumference, or 2 pi r is the other. Now, if you need to hit pause to write this down, please do so. Write down as much as you need to, but make sure you know the formulas. And sometimes it's helpful to have the formula with diameter. Remember, a diameter has to be written. So if they ever give you this length, by the way, let's say they said this. This is a diameter because it shows the distance all the way through the center. So its circumference then would be 10 pi centimeters, just centimeters, because it's just perimeter, it's just length, so it's just 10 pi. Okay? If I wanted to use the radius, I'd have to cut this in half and say it's 5. 5 times 2 is 10. 10 pi, you get the same answer. But feel free to pause this and finish writing anything you need to. All right, the next example. My car tires have a radius of 35 centimeters. How far does my car travel in 30 revolutions? If you want to draw a picture of this, you can. What do we have? We have a tire. It's a circle. 35 centimeters is the radius. And if I travel around there once, the distance around one time, that's 1 revolution. Right? But now I'm going to go 30. Well, 1 revolution is the same as a circumference. So I need to find 2, and notice I'm given r. So circumference, which is 2 pi r, is equal to 1 revolution. Well, let's find the circumference. 2 times pi times 35. Now, 2 times 35 is 70. If I call that 70 pi, this is considered my exact answer. I just want you to be aware of that. When we say exact answer, it means you just leave pi in it. If you want a rounded estimate, then you're going to do 70 times, and use the pi button in your calculator. Don't use 3.14. The reason why is the pi button is more accurate, and we always want to round to 3 decimals. All right, so now I would prefer, unless they ask you to specifically use decimals, to use the exact answer. Why? We're not rounding here. This is more accurate than the rounding answer down here. But that's 1 revolution, right? I need to go 30, so I'm going to take that answer, I'm going to times it by 30, and it says, how far does my car travel? Well, 30 times 70, the total answer, or total distance, is 2,100 pi centimeters. But people are going to look at you pretty crazy if you just say that, right? So when we have real life problems, it's usually better to take the non-exact or the rounded answer, because that makes a little more sense to people. And again, round to the nearest third decimal. But here's the exact answer for total distance. All right, so how far does my car travel? There's the exact answer. There's the rounded answer. Now, how many revolutions do the tire make in 1 kilometer? Well, we know how far. What we have to do is we have to figure out, well, wait a minute, how far is 1 kilometer? I know that 1 revolution is 70 pi, right? 1 revolution is 70 pi centimeters, but how many centimeters are in 1 kilometer? And that's the idea here. We had to just kind of give you this fact. In 1 kilometer, that's equal to, let's see, 1, 2, 3, 100,000 centimeters. So all I'm going to do is take this total distance and divide it by 70 pi. Okay, notice the centimeters are going to cancel out. If you do this exact answer in your calculator, just go ahead and make sure you put parentheses around the 70 pi. And how many revolutions? We're going to get 454.728 revolutions. That's how many times it would go around if we traveled 1 kilometer. All right, now here's the big part for today. So hopefully you guys understand and are comfortable with circumference. We're going to talk about something called arc length, which we've never really talked about before. It does have to do with the central angle. So I really want to make that connection to chapter 10. And remember, when we say central angle, if, for example, this was 100 degrees, remember the arc measure right here was also 100 degrees. That's something we have to kind of have a familiarity with. So an arc in a circle can be determined in 2 ways. We can call it the arc measure, which is the amount of central angles that intercepts the arc in degrees. That's what I just did in red. This is the arc measure in degrees. But how long is that? Right? When we talk about length, length has units, right? The units in measure, the arc measures degrees. But what about length? Well, that length connects to the radius. So let's say, I don't officially know, but let's say the radius is measured in inches. Then the length of this arc, how long is this arc from here to here? Well, it's a portion of the circumference, and that length, whatever it might be, is measured in the same units as the radius is. So it's like if you were walking around from A to B, how far would you walk? Right? You don't talk about that in degrees, you talk about it in units. So how do we find the measure of the arc? Well, it's right here. How do we find the measure of the arc from A to B? So how long is that green segment? Or I'm sorry, how can we use the measure of the arc? So how can I use the fact that it's 100 degrees and compare that to the length of the arc? Well, we have a special theorem or a corollary. It says in a circle, the ratio of the length of an arc, which by the way, you can pause this in a second, but the length of the arc, we're going to use a lowercase l to represent that, over its circumference. So the ratio of L over the circumference, wait a minute, circumference, we usually use 2 pi r here. So arc length over circumference has to equal the ratio of the arc measure over 360 degrees. So then we usually use this symbol as arc measure. Well, wait a minute, isn't that arc measure the same as the central angle? So in this case, I would put 100 here, because 100 out of 360 gives me this portion of this circle. So however many degrees their central angle is out of 360, that's the same ratio as the arc length out of the circumference. All right, so you can pause this and get caught up. I'm going to move on, and we're going to do a couple problems here today. So if you need to pause this to draw these pictures, please do so. But let's take a look at what we know. So the first one, I know my central angle is 105, which means the arc from A to B is 105. And then I have to find the indicated measures. So they want me to find the length. Notice, length of the arc from CAB. That's a major arc. So I want to go from C through A all the way to B. And I have to find that length. Well, wait a minute. If this is 105, 360 minus 105, that gives me 255. I'll put it down here. Okay. So this length measure, the measure of the arc is 255, but I want to find the length. I want to find how long is it if I travel around the circle from here to here. So let's take a look. Well, what is my formula? It's arc length over circumference is equal to the central angle, or the measure of this arc. And in our case, it's not AB, it's CAB over 360. So what do we need to do? Well, I don't know what the length of the arc is. I need to find that. I do know the radius. The radius is 15, so I'm going to put 15 in here. And then I know that CAB, now they didn't give it to me, I had to find it. This length is 255 degrees, or I should say measure, and this arc is 255 out of 360. So notice, I know everything but the arc length. Okay? And you might want to pause it to get caught up. I'm going a little fast here. But what do we do now? We're going to cross multiply and solve. Now notice, this is 30 pi, which is my circumference. I'm going to do the exact answer. So I'm going to leave pi out. I'm going to do 30 times 255. And that is 7,650 pi. And then that's going to equal, what if I cross multiply the other way? 360 times L. So I'll divide by 360. I get 21.25 pi as my arc length. Now notice that's length. So let's look at my units. 15 inches. So the length around this shape would be, this is the exact answer, 21.25 pi inches. Well, what if I find the rounded answer? So I'm going to do 21.25 times pi, and that would be 66.759 inches. Okay. So we might ask you to find the exact answer or the rounded. You should be prepared to do either one. Exact just means leave pi out of it until your final answer and write pi in. Okay, so that's the very straightforward way. Find the length of the arc. Well, the other examples, what if they give me the length of the arc and they ask me to find something else? Let's look at this example. And again, pause this if you need to draw out the picture. Maybe you want to work the problem ahead on your own. But let's look at what we have. They give us the central angle, 75 degrees. So if the central angle is 75, its measure of the arc DF is also 75. But then they give me a length. Now, how do I know this is a length? Look at the units. That's arc length. So the length from DF is 6.82. And they're asking me to find the circumference. So if I use the same formula over here, notice L is 6.82. But then they say find the circumference. Well, wait a minute. Isn't 2 pi r the circumference? So instead of putting 2 pi r here and solving it, that would give me the radius. I'm just going to put a c, because c stands for circumference. And then that has to be the same as the arc measure. Now this arc measure is the same as the central angle, or 75 over 360. And then it's a really quick cross multiply and solve. And then divide by 75. I get 32.736. And now I have to be thinking, okay, wait a minute, circumference, that's the length around the full circle. That's 32.736. Now notice, if I plug that back in, if I did the arc length, 6.82 divided by the circumference, whatever this decimal is, should be the same as 75 over 360, because those ratios are equal. All right, now notice the next one. Here they're saying find the measure of the arc. So this is arc measure. And I already know whatever my answer is, it's going to be in degrees, right? Because that's arc measure. That's the central angle, or it's the measure of arc. It's what I did in red for all the rest of these. Well, what else did they give us? This is a little bit out of whack. This length right here is the radius. 15.82, it got kind of shifted. So there's my radius. And look at J to K. They put a length out here. So that's the arc length. So I'm going to say 40. Now notice that's L. 40 over circumference. Well, I have the radius, so I'm going to do circumference here. 2 times pi times whatever that radius is equals the measure of the angle, and that's what we want to find, is JK over 360. So then what I would do is I would just do this part first and figure out what that is. Notice there's a decimal here. Let's take the rounded answer. So let's actually use the pi button. And I'll get 96.007. So I'm going to cross multiply. And I'm going to do 40 times 360 in my calculator. Equals 96.007. And if you want to be even more accurate, you could take all of the decimals in your calculator. And then we just got to divide by the circumference over here. And that will give me 149.989 degrees. And that is the measure of JK. So that's the central angle as well as the measure of this arc in degrees. Okay, so that's how we do arc length. Sometimes we're looking for arc length. Sometimes we're using the arc length to find the circumference. Sometimes we're using both the arc length and the radius to find the measure of the angle. Okay. Now notice, what if I asked you to find the radius here? I should have maybe talked about that here. If I do this problem and I find the circumference, I could also ask you to say, well, what's the radius? Well, all you do is take this answer, and this answer is equal to 2 pi r. That's the circumference, right? So then all you would do is divide both sides by 2 pi. If you're using your calculator, which you should be, make sure you put parentheses around that 2 pi. So if I asked you to, we could also find exactly what that radius is right here. So that's just an extension for that problem. Okay. We got one last problem. Obviously, you're watching the video, so you don't have to do this part. But if the circumference of a circle is 12 pi, find the diameter. Go ahead and hit pause and try these problems, and then I'm going to go over them shortly. Okay. Now, circumference is 12 pi. Find the diameter in feet. Well, if they're asking me to find the diameter, I'm going to use the circumference formula that has diameter. You could use the one that has radius and then just get your answer and change it from a radius to a diameter. But in this case, 12 pi is equal to pi d. Really quick, divide by pi. Pi's reduce out. And nothing special. It's almost an insult to your intelligence, right? 12 feet is equal to the diameter. Okay, next one. In circle B, measure of ABC is 126. Now, this should say degrees because it's the measure of the angle. So they're saying that this angle right here is 126 degrees, which means its measure of the arc is also 126. AB is the radius. Find the length of AC. So they're asking us to find L. And we know that this answer is going to be in regular units. If they had said feet, we'd say feet, but they didn't. So I need to set up the formula. Arc length over circumference, an R, is equal to the measure of the angle, in this case, the arc AC over 360. So we want to find L. We know the radius is 12. And then AC, they gave us as 126 over 360. And notice they said round to the nearest 100th, which means you don't need to use the exact answer. So I know that this would be 12 times 2 is 24 pi. I'm going to do that in my calculator. 24 pi, and then I'm going to multiply it by 126. And if you want, you can take the whole answer for right now. We usually say take the answer and then round at the end. And that's equal to 360 times L. Then take that answer, divided by 360. And they don't give us units, so this would just be regular units. There you go. All right, your homework tonight is a Delta Math assignment. Now I want you to really pay attention to this. 11.4 and 11.5. We only learned 11.4 today. We are going to learn 11.5 on Thursday, Friday. Today is Monday, Tuesday. And you're only going to do the first part. Okay, so do circumference, circumference level 2, and arc length. And then it says stop. Okay, you're going to stop here. And the next work is 411.5. Now you could do area of a circle, but we haven't talked about area of a sector yet. So don't do that. And then this assignment, since we're splitting it up from this week, it's not going to be due until Friday, the 29th at 3 o'clock. And then when you're done, you'll just submit a screenshot of your completed work to Schoology. So you don't have to submit anything today. You just have to do these 3 pieces, and then there's a spot where it says stop. That's all I have. I will not be available in my office hours today. So I will see you all on Thursday. Have a great day.